Hey y'all, I guess most of you subscribed to this channel probably forgot that it existed until you saw it on your feed just now. Anyway, after a little while, I'm back. Why did I leave? When I made the first few streams, I was looking for a new hobby, so I decided to give YouTube math streaming a spin. It was fun, but I didn't feel I was making especially good streams, so I stopped. And looking back on it, it was pretty true, and as such, I've unlisted the old streams. Hopefully this will be a little bit better. The more important reason for that, though, is that I found an even better hobby, until a certain virus stopped me from doing it. Now I am a sad, lonely man looking for something to do to cheer myself up and keep busy in this sad, lonely time. Why not do a sad, lonely activity like math, but now about dancing? Two negatives cancel each other out to make a positive. So this might just work. Let's say you're at the dance club and you're trying to get a few dances. Everyone there is a much better dancer than you, way more attractive than you, and knows everybody else in the club. Well, we're here to make some friends. How hard can it be? If you're trying to take care of number one, yourself, very. Well, you start out and meet this cutie. She introduces herself. His name is 2. Okay, weird, whatever. You dance, and then she introduces you to her boyfriend 3. Okay, cool. Then you dance with a girl named 4, she used to date 3, now she hates 2, but it's alright because she's dating 5, who's cheating on her with 6, who also has a crush on 3. And then there's 32, 36 owes 25 years ago, 75 47 is just sitting in 1 is going to Calico, 67 decided to get 27 engaged, 2 for 2. Yeah, sorry about that. Let's slow down here a little bit. Never mind how complicated these relationships are, just let's ask a simpler question. How many are there? Let's start even simpler. How many people are there? Oh look, here, we have n people. How convenient. Now we want to ask ourselves, how can we keep track of all these people and all the relationships between these people? To do this, I want to introduce y'all to a graph. Not a graph like what you learned about in kindergarten or algebra or calculus or whatever. A graph like this. It's made up of 2 parts, vertices and edges. Vertices are the elements of a set. In this case, we're going to use people as our vertices. The number of vertices in a graph is called the order, and in this case, the order is the number of people, n. The other part of a graph are the edges. These are the connections between 2 vertices on a graph. Now, there are 2 types of edges that we can talk about, directed and undirected edges. Directed edges are when one vertex is related to another, but not vice versa. For example, all these new people in this new dance club, they all hate me, but I have no strong feelings about them one way or another. Undirected edges have no such distinction. For the most part, we'll care about undirected edges, but for tonight we'll actually need a little bit of both. If the edges of the graph are directed, our graph is called a directed graph. If not, it's just a graph. The number of edges in a graph is called the size. Also note that we're not going to allow for multiple edges for now, nor will we permit edges between a single vertex, also called a loop. So what is the size of the graph here? As I stated before, everyone knows everyone else. A graph with that description will look like this. This is called the complete graph of order n. We will denote this graph k sub n. Cool. How many edges are there? Let's start by counting the number of possible directed edges. Let's look at ourselves at vertex 1. We know n minus 1 other people. The cute vertex number 2 also knows n minus 1 people, as does her boyfriend at number 3, and so on and so forth. We have n people who know n minus 1 other people. That means there are going to be n times n minus 1 directed edges in this graph. To find the number of undirected edges, let's look at the graph. An astute observer will see that each undirected edge will always correspond to a pair of directed edges. So, we can count the number of undirected edges by counting the number of directed edges and dividing it by 2. The anxious student here might worry that this will produce a non-integer value of edges, but recall that if n is odd, then n minus 1 must be even, and vice versa. Now this is a well-known elementary result in graph theory, the study of these graph objects. In future videos, I would like to go over graph theory with a little more dancing context added to it just to make things a little more interesting. I don't want to just sit here and give you lecture slides or something. I want to add a little more flavor, context to this subject. It's a beautiful subject in my opinion, and I hope you guys like it too. See ya.